This video talks about how to construct the sample standard deviation control chart, the S chart. Last Thursday, we discussed the X bar chart and R chart to describe the central tendency and the dispersion of our sample data, respectively. So for the subgroup sizes that is greater than or equal to 10, the range is no longer a good measurement of dispersion, and therefore we need to turn to the sample standard deviation to describe the dispersion of samples within one subgroup, and therefore we need to construct this S chart. So here are the trial central lines and control limits using the X bar chart and S chart. So the SI stands for the standard deviation, the sample standard deviation in subgroup I, and then when you sum up all these SIs and then divide it by the total number of subgroups, then this gives us the S bar, which is the central line in our S chart. And for the S double bar, we compute it in the same way as we discussed last Thursday. So for the control limits, we assume that the upper control limit and lower control limit for the X bar is the X double bar plus and minus the A3 times the S bar value. So the A3 should be the value that you look up in table B associated with the subgroup size, the number of samples in one subgroup. Okay, and then for the upper control limit and lower control limit for the sample standard deviation, we use the B4 and B3 as a multiple to the S bar value. So this B4 and B3 are also defined as a constant factor in our table B. And note that there's a typo in page 203 of our textbook, so there should not be a bar above this SI. Okay, you should go with this definition. So after we obtain the trial control limits for X bar chart and S chart, we can find some outliers, the points that are beyond control limits. So if these outliers are presented because of the assignable causes, then we need to discard these points and to find the revised limits for the next round of inspection. So in this case, this SD is the discarded subgroup sample standard deviation, right? And then this GD is the number of subgroups that has been discarded. And then we can find the updated X double bar and the updated S bar. And we need to find these standard values, the X bar 0 set as the same as X double bar new, and then this S0 set as the updated S bar, and this sigma 0 defined as S0 divided by C4. And then use these four formulas, we can find the upper control limit and lower control limit for X bar and for the standard deviation, respectively. So the C4, A, B6, and B5 are the numbers, the constants that we need to find in table B. And notice that in table B, this A value equals to the A3 times C4. So if you want to plug in, so if you replace this A with the A3 times C4, then you can see that the upper control limit for X bar is the same as the X double bar new, the updated X double bar, plus the A3 times the updated S bar. So these are consistent with the formula that we used in the previous slide. And they just compute the equivalent revised limits. Here is the same example as we discussed last Thursday on the data on the depth of the keyway, right? So for each subgroup, we have 4 samples. And of course, using the R chart is good enough, but it's no harm to investigate this S chart, right, to compute the sample standard deviation. So what recorded in this column is the sample standard deviation for each subgroup. Okay, so this SI is defined as the sample standard deviation of these 4 points, right? You already have computed this X bar, the average of the subgroup. So you can use each data point minus the X bar and then square them up, find the sum, divided by n minus 1, 3, and then take the square root, right? This is how you compute the sample standard deviation for each subgroup. And now you sum up all this sample standard deviation for all the subgroups, right? And then divide it by the total number of subgroups, 25, and then you can find this S bar value. And then this X double bar is computed in the same way as we discussed last Thursday. And now for the control limits. So you need to look up the A3 value, B4 value, and B3 value in table B in our appendix associated with the subgroup size, which equals to the number of samples in one subgroup. So we have 4 samples in one subgroup. Then you need to find this A3, B4, and B3 value associated with the subgroup size of 4. And now you can plug in the X double bar and S bar that we computed here, and then plug in these factor values, and then to find the control limits. So here are our X bar chart and S chart. On the top is the X bar chart, and in the bottom, this is the S chart, the sample standard deviation chart. Okay, so we see that there are 3 outliners for the X bar chart, and we need to discard the points, the subgroups that are beyond the control limits because of the assignable causes. So we need to discard the subgroup 4 because there's a new operator, the assignable cause, and we need to discard the subgroup 20 because we have the assignable cause, the bad material. However, we do not discard this subgroup 16 because there's no assignable cause. It is assumed to perform normally, but then it is out of the control limits, so we still keep this for the revision. Okay. And now for our S chart, we have only one outliner here in subgroup 18, and we identify that there is an assignable cause, the damaged oil line, so we have to discard this point. And you need to discard points respectively for these 2 charts. So you just discard these points independently from each other. You discard 2 points for the X bar chart and discard 1 point for the S chart. Sorry. On this slide, we compute the revised central lines and control limits. So as you can see, the updated S bar new discard this subgroup 18, right? So you discard the value, the standard deviation in subgroup 18 in the enumerator, and then in your denominator you minus 1 because you only have 24 subgroups now. And here we find the updated S bar new, and then you find the updated X double bar. Also from table B, we find this constant factor, the C4 equals to 0.9213, and then you can find the standard values, this sigma 0. And now you can plug in to the revised control limits formulas, and then to update the control limits for X bar and the control limits for the sample standard deviation. One thing I want to notice is that the sigma 0 value that we computed for the R chart, as we discussed last Thursday, gives the consistent value of this sigma 0 value computed by the standard deviation. This is because this sigma 0 stands for the short-term standard deviation, or an estimate of the true standard deviation of the samples, of the 4 samples. Okay, so they should be the consistent values, and they should give us the same revised control limits for the X bar chart.